think you should be able to hear me, and I hope you are able to see my screen. I have the live stream open so I can check once the live stream catches up with the real world, but let's just get started. So as introduced, I am going to talk to you about Knock Knock Who's There, and if you have no idea what that means, I'm going to try to talk to you today about token-based authentication and JSON Web Tokens in general. But before I do that, let me quickly introduce myself. My name is Bellen. I'm a developer advocate engineer at Auth0. And if you've never heard of Auth0 before, we have a sponsoring booth here at the conference, but let me quickly tell you what we do. We're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow so you can focus on building your actual products. I'm also a Google developer expert, and you can find me on the internet as @Sambego. So if you have some questions for me during this talk or after this talk, feel free to send me a tweet or find me on other social networks, and I'll be sure to answer those questions as soon as I can. So what we're going to be looking at today, we'll start off with a little bit of traditional authentication, or at least what I consider traditional authentication. Then we'll transition into tokens, and we'll talk about what tokens actually are. And then we'll lastly see a little bit about token-based authentication. So, traditional authentication. What do I mean by traditional authentication? Imagine this scenario, and I think we've come across this scenario, all of us. We come across it every day, probably. So if a user that visits your website, and if the website does a call to the backend server, to your logic in the backend, and that backend is going to generate a page. And that works well until the user tries to access a page that is protected, for which the user needs to be authenticated. So what's the user going to do? Is going to enter a username and password usually, and we're going to send this through the browser to the backend. The backend is going to validate this, and if everything is correct, the backend will return the page the user requested. But it will not only return the page the user requested, it will also return a cookie, which will be saved in the browser. And every next time that the user wants to access a protected page, the browser will send that cookie. And if that cookie is still valid, or the session inside of that cookie is still valid, the backend will be like, yeah, sure, you can access this page, and return you this page. This is a very common example. We see this all the time. We see this with traditional based applications, which are most commonly applications that are generated on the server, and all the logic is on that backend, on that server. But there are a few differences between traditional web apps and single-page applications, the applications we'd like to make these days with JavaScript frameworks like Angular, React, Vue, Svelte, doesn't matter. And the first one is a traditional architecture is often one-to-one. You have your application that works with one backend. This can be a huge backend, and that backend can maybe consume 1 million microservices. But that one backend is going to consolidate all of that logic and generate the HTML page and send it back to the browser. So it's more a one-to-one relationship. Whereas a single-page architecture is often a one-to-many. Maybe you have an API on a certain domain, and you have your authorization or authentication server on a certain domain, and maybe you handle payments on another domain. You have 3 different domains, but they're all part of your backend logic. And then your applications, your single-page application, also lives on a separate domain. So it's a one-to-many relationship. We also have a multi-architecture. Maybe you have a mobile app, maybe you have a desktop app, maybe you have a web app, sometimes all 3 of them at the same time. And if I would ask you who has one of those, I would probably see some hands going up, but we're all in our own homes, so you don't have to really raise your hand. But the funny thing is, only the web uses cookies. So it would be nice if we could use the same form of authentication, or more or less the same form, for both mobile, web, and desktop apps. So what are some of the problems with this traditional cookie-based approach? The first one is going to raise a few of these hairs on your arms probably. Cookies don't like CORS. Nobody likes CORS. If there's somebody here attending this talk who says they like CORS, they're probably lying, because nobody knows how it works. If you encounter a CORS problem, which is cross-origin resource sharing, you Google what's my CORS problem, you end up with Stack Overflow, and you just copy-paste the first response you find, because it's a very complicated matter. Cookies also require state, because most of the time inside of these cookies is just a session ID, and that session refers to some state inside of your database stored on the back end of your system. And cookies don't flow. You cannot pass a cookie issued to a one domain and use it on other domains, just because cookies are always tied to domains. But our more modern servers, as single-page applications, sometimes do require data from multiple domains. So that can be an issue if you want to work with cookies and single-page applications. For example, if your main API wants to query some user data from another authorization server, in theory, it's not possible to do this with a cookie just because a cookie is issued by the first domain and cannot be used by the second domain. So what's the solution? Maybe it's token-based authentication. We'll see what this is by the end of this talk. But before I talk about token-based authentication, I first have to talk about tokens. So what is a token? To me, a token is a unique identifier representing something, and this is something that's meaningful to me. It doesn't really matter what this token looks like, as long as I can take this token and get some meaningful meaning from this token. That to me is a token. And there are a bunch of different kinds of tokens. Maybe you've heard of an access token before. Maybe you've seen an ID token, and maybe you've even heard of refresh tokens before. These are a few different types of tokens that all do something different, but they're all considered a token. They're often an opaque string in the form of UUID, which means they're often an ID which refers to something in your database, so you can get more meaning from that ID by looking in your database. But they don't have to be. If you've worked with SAML before, SAML tokens are a bunch of XML. It's an older standard, that's why it's XML, but the token itself is just a bunch of XML. And they can also be JSON, especially when you use Json Web Tokens. And that's what I actually want to be talking about today, Json Web Tokens. At Alt0, we use Json Web Tokens as much as possible, just because we think they're very powerful and we like to use them for our own convenience. And if you've never seen a Json Web Token before, this is a Json Web Token. And if you've seen one, you may or may not have noticed that they usually consist out of 3 parts. I say usually because sometimes they can contain 5 parts, but 99% of the time they're only 3 parts. The first one in red is called the header, the second part in purple is called the payload, and the last part is the signature. So a Json Web Token most of the time has 3 parts. And the first one, like I mentioned, is the header. Now, this is not just some random gibberish or some random characters. This actually has some meaning. And what it is, it's a base64 encoded JSON object. And this JSON object will contain some meta information about the token itself. It's called the header, and it usually contains which algorithm has been used to create the signature, which is a third part of the token. And it also tells us, hey, the type is a JSON Web Token. So we know that we're dealing with a JSON Web Token here. So if you take that first part and you decode it with a base64 decoder, you'll end up with something JSON-like, a JSON object, which might look like this. The second part, again, not random data. Again, it's base64 encoded JSON object, which will contain some more information, which is useful to the purpose of which we are using this token. And this will get clearer in a minute. But it's just a bunch of JSON, and anything you put in this JSON, you put in the payload, is valid as long as it's valid JSON. So there's a bunch of different things you can put in these, and the first ones are reserved claims. And these are just key value pairs that are specified in the Json Web Token spec. Things like subject, which is usually the user ID, the issuer who issued this token, when it will expire, when it's issued, and some other of these claims are all listed in the specification of the Json Web Token, which is also known as the Jose specification. The second type of claims are public claims, and these are claims that are often used with APIs or with tokens, but not necessarily specified in the official JSON Web Token spec. They are, however, listed on the IANA page. So if you switch to the IANA page, there's a whole list of these claims, because we tend to use them a lot with tokens, and it's just so we can have a better API interoperability. So if you look at this, maybe you would say first name instead of given name, or last name instead of family name. But if you want to conform to this IANA list of claims, you might use given name, family name, and so forth. And lastly, private claims, and this is anything that is important to you or the party that wants to consume the token. As long as it's valid JSON, you can put it in here. It's all good. Strings, booleans, whatever you want, even arrays or objects are okay. But don't put sensitive data in the payload, because it's just a bunch of base64 encoded JSON. So everybody can go to decodebase64.com, put in that payload of the token, and see what's actually in there. So do keep in mind when you are putting some data in the payload that you don't put anything sensitive in there. Also, these tokens are often going to be sent over the internet with a lot of requests, so try to keep them as small as possible. Only put something in there that is relevant to the party that's going to process or use that token in the end. So we've seen the header, we've seen the payload. Third part is the signature. And what we do to create a signature is first we check in the header, what we do to create it is we choose an algorithm and put that algorithm in the header, and then take the header and the payload, concatenate those, and then run them through that algorithm. If you have HMAC, for example, it uses a shared secret. But if you use RSA, you will probably have a private key to generate the signature and a public key to validate it. So once we've generated the signature, we'll put that algorithm in the header. And if a party wants to verify those, they can, with HMAC, just use the same secret that you used to create the signature, and with RSA, use the public key to validate that the signature is true or false. But this means that if something changes in the header or in the payload, the signature will also be changed, because we use that data in the algorithm to create the signature. So some real-world examples of tokens. An access token, when you use a Json Web Token for an access token, might have a payload that looks something like this. It will contain some data that is interesting to an API, because an access token is usually used to get access to an API or to an API endpoint. So it says, gives you some information about the issuer, the user, which is a subject, the audience, which API can consume this, when it's issued at, expiry date, and maybe some of the scopes that were granted to this access token. Well, if you look at an ID token, which has something to do with the identity of somebody that authenticated with OpenID Connect, it will contain a bunch of information that is related to the identity of somebody that authenticated, and in which we can return this token. So the nickname or the name or an avatar picture, and again, an issue date and an expiry date. JSON Web Tokens are part of the HOSE specification, which stands for JSON Object Signing and Encryption. So there's things like JSON Web Tokens, JSON Web Keys, JSON Web Signature, and a JSON Web Token, the one we just saw with the 3 parts, is actually just a JSON Web Signature specified as a token. And if you want to have the one with 5 different parts, like I mentioned before, you'll have a JSON Web Encryption, which means that the payload will also be encrypted. It's a bit more complicated, not used as much, but it's also a possibility. So let's make a little comparison. On the right, you have my passport. It's a Belgian passport written in 4 languages, because we like to make it difficult in Belgium. And on the left, you have the header of a payload, of a JSON Web Token. And it tells you a bit about what it is. My password is a password issued by the Kingdom of Belgium. The header tells you I'm a JSON Web Token, and the signature has been created with this algorithm. Same thing, if you open up your passport, there's a bunch of information about the bearer of that passport, in this case about myself. Well, if you look into the payload of a JSON Web Token, it will tell you some information about who is issued to. If it's an ID token, it's identity information. If it's an access token, it will be information useful to an API. And lastly, each passport has a bunch of measures to make sure that it is not a fake or a forged password, like passport, something like maybe a fingerprint or some holograms. And a JSON Web Token has a signature, which lets you validate the validity of a JSON Web Token. So let's see it in action. I have this cute little demo, which has 2 buttons. The first one shows you a random dog picture, and the second one shows you a cat. But if you own a cat, you know that cats are a little bit less easy than dogs, let's say. So I need to log in first. So when I log in, I will be redirected to my Auth0 tenant. I'll log in with Google. And once I finally authenticated, you'll see that my personal information appeared on the top right, because then I got an ID token back. And as we've seen before, an ID token contains some information about the identity. I also got an access token back, which means that I can send this along to request pictures of cats. All right, let's keep going. If you want to know more about JSON Web Tokens, there's also JSONWebToken.io, JWT.io. It has a bunch of different of information. It lists a lot of libraries in a lot of different languages, and it also has a nice debugger that lets you debug or create JSON Web Tokens, as seen here. We also have the JSON Web Token handbook on our website. If you want to know every dirty little secret and every detail about JSON Web Tokens, I recommend you read this book once you have a little bit of extra spare time. So we've seen traditional authentication. We've seen what a token is. Now let's look at token-based authentication. So again, the same scenario, a user visits your website and the website is going to request some data to your backend. In the case of a single page application, that's often an API. And that's all fine until the user wants to request some data that is protected, an API endpoint that is protected. So the user, again, provides the username and password. We're going to send this to our API. And if that data checks out, if the username and password is correct, we'll send back the data, but we'll also send back the access token. And instead of a cookie, we'll just send the access token, which we'll store in the browser. Depending on your authorization server and some other factors, you might store it in local storage in a cookie or in memory, which is often the most safest solution after all. And then for each request to a protected endpoint, we'll send that access token again, just to prove that we have access to that protected endpoint. So it's much like the first example, but instead of a cookie, we just use the access token to get access to protected data. And once that access token proves to be okay, still valid, expiry date inside of Json Web Token is not expired, the signature is valid, and all of that, we get our data back. So a little note about access tokens and Json Web Tokens. OAuth and OpenID Connect do not specify what format an access token should be. They do not have to be Json Web Tokens, meaning that an access token can be in any form you want. Maybe an access token, maybe a UUID. It doesn't have to be a Json Web Token, but there is an IETF, an Internet Engineering Task Force draft to standardize this. So if you want to use a Json Web Token as access token, you kind of have a standard you can follow if you want to. ID tokens, however, are always Json Web Tokens. They are specified like this in the OpenID Connect specification. Also a note about refresh tokens, because I know this is something that comes up a lot. If you want to use refresh tokens in single page applications, using refresh tokens in the front end should be avoided because they're not as safe in a single page application as they are on a backend, unless a system of refresh token rotation or sender constraint is in place. For example, at Auth0, we have a system of refresh token rotation in place, which means that we will rotate those refresh tokens as soon as they have been used. We'll issue a new one. So they're okay to use with a single page application. But if you don't have refresh token rotation or sender constraint in place, try to avoid using those refresh tokens in the front end. So, does this approach solve for CORS? I think it does, because a JSON Web Token or a token, an access token in general, it's usually not issued to a domain. It's just a token, and as long as your API or backend knows how to validate this, knows how to validate the expiry date, knows how to validate the signature, you can use it. Doesn't matter from which domain you're working at that moment. Does this approach solve for flow? In theory, you can pass along these tokens from one backend to another API to another API. You're usually going to exchange those with the token exchange endpoint, but in theory, it could solve the flow issue as well. And does this approach solve for keeping state? Well, all of the state is usually inside of the payload of a JSON Web Token, the expiry date, who it's issued at, and so forth. So it could be a solution to keeping state in a database if you already have all the details you need inside of that JSON Web Token. So let's summarize. I went quite fast, but these slides are online and I'll share the link in a second. Using session cookies is hard with single page applications just because cookies are often tied to a domain and we often end up with CORS issues when we are working with single page applications and multiple APIs. JSON Web Tokens usually consist out of three parts: the header with some metadata about the token itself, the payload with the actual content, and the signature which lets us validate the validity of the content in that JSON Web Token. And lastly, tokens offer a bit more flexibility when working with single-page applications, just because they don't deal with all of those issues that cookies often have to deal with. If you want to know more, jwt.io. We also have a blog that goes a bit more into why the implicit flow with OAuth is not advised anymore and what you should do instead. And our blog also has a bunch of other really useful articles. My slides can be found at jwt.sambego.tech. These slides will always be here. They will be ever changing, which means that I update them regularly, but the basic content will always be the same. That being said, 1 minute left. Thank you very much. I hope you enjoyed this and enjoy the rest of the conference.